All right, this is going to be going over the answers from the quiz that you guys took 2 weeks ago on 9/28. All right, so if the position time graph is horizontal, it means that an object is at rest, right? I'm not changing my position. Right? If we have a slope like this, it means that I am moving with a constant non-zero speed. If I have a slope like this, it means that I'm moving with a constant non-zero acceleration. And moving with an increased speed is the same thing as accelerating. The slope of a displacement time graph gives me velocity. If the velocity time graph of an object is horizontal, it means that I'm moving at the same velocity. So a constant something non-zero speed. Moving with a constant acceleration would look like this on a velocity time graph. When you're at rest on a velocity time graph, it's right at the x-axis. And you're moving with an increasing speed is the same thing as when you're accelerating. So it is this horizontal line. A ball is thrown straight up from a location where the acceleration is 9.8. How high does the ball go? So I've given an initial velocity. My final velocity is 0 at my highest point. My acceleration is negative 9.8. And I'm looking for my height. So I'm going to use this equation, y. And I'm going to use y because we're moving in the vertical direction. Right, if this is 0, I can rearrange my equation to find my height. I'm going to do a few steps in one. I'm going to subtract vi squared from both sides, and then I'm going to divide by 2g. So negative vi squared, well, I guess I'll do 2gy. Then I'm going to divide both sides by 2g to get the y by itself. And then I plug in my numbers. So 15 squared, this should be negative from my equation, and then the negative from my acceleration should cancel out. I should have some positive vertical displacement. And if I recall correctly, I think it's B. All right, determine the height of a bridge. Drops the stone 2.3 seconds later. What is the height of the bridge? We want the equation with time and height. So we are going to use my height is equal to my initial velocity times time plus 1/2 my acceleration times squared. My initial velocity is 0 of an object that's being dropped, and then I just plug in my numbers. So 1/2 times negative 9.8 times a time of 2.3 squared. And what is that? I want to say 14. Nope, 26. Okay. So plugging it into my calculator. So this asks for the height of the bridge, right? The displacement is going to be negative, but it's asking for the height. So we're going to find our displacement, right? But our height of a bridge or a cliff is going to be positive. A baseball catcher throws a ball vertically upward and catches in the same spot as it returns to the mitt. At which point of the ball's path is it experiencing 0 velocity and non-zero acceleration? The acceleration is non-zero the whole time, right? It's negative 9.8 the whole time. The only time where it is 0 is at the highest point. So if I throw a ball up, it's going to stop and then it's going to come right back down. So at the top of its path is when the velocity is 0. Acceleration due to gravity is also called free fall acceleration. A rock is dropped from the top of a cliff and strikes the ground 3 seconds later. How high is a cliff? We're going to use the same equation we used here, except for we're going to plug in the variables from the equation. So initial velocity, because it's dropped, is 0. So 1/2 negative 9.8 times my time squared. .44. Ball is thrown straight up as it rises to a maximum height. This is my y, is above its launch point. We're looking for initial velocity. I know that at the highest point, my final velocity is 0. My acceleration is negative 9.8. The equation I'm going to use is the same one we started with here, but now we're looking for the initial velocity. So I'm going to keep my rearranged vi squared. Negative vi squared is equal to 2gy. And then I'll square root both sides. So 2 times negative 9.8 times 24 and square root. So .21 is my initial velocity. My initial velocity's got to be positive. So this negative in the equation and this negative for my acceleration, they're going to cancel out, right? So I really will be square rooting a positive number. This one, what's the velocity of the rock? Right, same set of variables we used up here, except for we're looking for a final velocity. We know our initial velocity is 0 because it's being dropped. And we know our 3 seconds. So, gives me negative 29.4. All right, this is a velocity time graph. This one is an acceleration time graph, and this one is a displacement time graph. These are the 3 graphs that you should have drawn a few weeks back. You will be drawing another set of graphs this week that look exactly like this. Which of the graphs represents acceleration? It's B. Which represent displacement? It is C. So just a little note. If you have a curved slope like this, it is not acceleration or velocity. Right? Our velocity graphs will either look like this or like this. Our acceleration graphs have only ever been horizontal, right? Either at the 0 or somewhere horizontally, a non-zero constant acceleration, somewhere that has a 0 slope. All right, that's it.